The Sudoku strategy I'm going to show you today will seem unnatural, virtually impossible, maybe illegal to you, which is probably why this puzzle was included in the Sudoku Dark Arts pack. I will show you step by step what the strategy is, how it works, and on what puzzles you can apply it. Click below if you want to give this puzzle a go, and with that, it's solving time. Okay, you could start with a normal solve of this puzzle and go, I got these two ones here and this one, and I can solve for one right there. And with these two ones, I can solve for one right there. And then with this two and these twos, you know, I can put a 2 right there. And with these twos, I can put a 2 right there. And then with the 3s, you got this 3 cutting across. With these 3s, this is called Snyder notation. Anytime in a 3x3 block, you have 2 possibilities for a candidate. Mark it. In case you solve one of these cells, you can solve the other right away. No problem. These 3s act as a pointing pair, which means that they point down, and a 3 cannot be anywhere else along column 2, because if you put a 3 here, 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 or here, you'd have no place to put a 3 in block 1. And so in this situation, a 3 can't be in this spot anymore. And so you have these two 3s, means the 3 can go right there now. And you can actually go over here and look at the 9s and notice you had this 9 cutting across row 1, which gives us a pointing pair of 9s. And with the 9s coming down here, a 9 cannot be in this spot anymore. And so with these two 9s, you can actually solve for a 9 right there. Greetings, friend. If you're new to the channel, I welcome you to Smart Hobbies. Subscribe if you want to turn your passing interest in Sudoku into a fun and enjoyable hobby. I do want to thank Philip Newman for letting me feature his puzzles on this channel. I think you're going to learn something new today about Sudoku if you watch the whole video. And give me a thumbs up if you just want to learn something new today. Okay, I'm now going to do something I've never done on a video before. I'm going to start over. I'm going to erase all this because you could try and look and try to solve another cell here, and it will be extremely difficult. You run through a solver, it's going to tell you forcing change, which is basically you're just luck of the draw bifurcation until you figure out where you made an error and start over. I want to show you something way cooler than that, and it's using some mathematics, and it's using and knowing something about this puzzle and about Sudoku. So let's restart the grid. Okay, what we have to notice and we got to know is there are a couple things here. One, Philip put this in the section of the Dark Arts pack called Through the Looking Glass. So Through the Looking Glass is a clue that this puzzle has some kind of symmetry in it, just like a mirror. You're going to look through and you notice symmetry, that things kind of flip on its end. The other thing, every puzzle in this pack has a unique solution. It's called out that way. You can use, and you have to use the knowledge of that if you want to find this neat trick, this neat strategy that I've never shown before. So let's go with the symmetry idea. So the idea of symmetry is think like mirror in. So you want to look, and this is something that Philip has shown before with ranks, is the idea that these puzzles are part of a family. So this group right here, this 3x3 band, as you can call it, you could take this row and you could swap it row 1 with row 2. And that would be okay. This puzzle would still be a legal puzzle and it would still solve the same strategies as what you had before. And the reason is that this is a set of the digits 1 through 9. This is the set of the digits 1 through 9. And so just by swapping within these rows within the band, it's not a big deal. You can swap this row with this row. You can swap this row with this row. You cannot, though, take this row and swap it with that row. You can't because of the nature of these 3x3 blocks. So if you have a 3x3 block, same row, then you can swap within the band the different rows. Philip explained this on a Sudoku discussion with ranks. I'll put a link to that below. Very neat stuff. The other thing you can do is you can swap this band with this band if you want. You know, we'll put this in orange. I could take this grid, swap it up here with this grid, for this 3x3 block. Same puzzle, same required strategies, same level of difficulty. You can also do this obviously with the columns. So you could swap, right here. You could swap this band. You could swap the columns within the band. You could swap the bands around and you'll be okay. This idea is called automorphism. Okay, automorphism, and it's an idea pulled from mathematics. And an easier way to probably think of this is, let's get rid of all the colors. I think what you can understand easier is you could take these 9s and take all the 9s in the puzzle, and you could replace them with 8s. And you can take all the 8s and replace them with 4s. And you take the 4s and replace them with a different digit. And the puzzle is going to solve the same way, right? It doesn't matter if this is a 9 or an 8. For us, we just need a digit. Or we could put in colors. The same idea. That's another automorphism, right? It's a little bit change to the puzzle, but it's going to solve the same way. Well, the feature of the rows and bands can also be swapped around. The starting grid, the end grid is going to look a little different. It's going to definitely look different, but it will solve the same way. And so this is how automorphism works. This is a really cool idea, and we're going to use that to move some of these digits around. This is what feels weird and unnatural. But if you want to solve exclusive puzzle packs that do not require automorphism, click on the pinned comment. Join the Smarty Party. You can be my first Super Smarty at $25 a month, and I'll put your name in every video. So let's look here at these starting digits that seem to look similar. See how this sequence of digits is kind of like is symmetry of this one. This is kind of like a sideways M, and this one's like an ups, a sideways W. So those are symmetrical, right? You kind of spin them around, and this shape will look like that shape. Think like Tetris. Same with these and this. And by symmetry, it's like the 9 kind of equates to where 3 is. You could spin it a 180. The 4 would match with 7. The 8 would match with itself. The 6 and the 5 if you spun this around. This 1, 2 is kind of like this 2, 1. And then this 3 is by itself. And how this 9 is kind of like if you spun the 3 around, you end up in this square. That's kind of what the 9 is. So actually, these little blocks all have some kind of symmetrical or mirror block that goes with it. This block is a mirror of this block. This block's a mirror with this block. This block is a mirror of this block. This block's a mirror of this block here. And then you have one last block, the empty one. All right? So it's not a mirror, it's just onto itself. Okay? So what we can do, and like I told you about moving bands and moving rows, is we can move some of these bands around. So I want to match this block with that block, right? And what we can do is we can get this block up here and this block to the bottom, we can match them up. So what you can do is we're going to swap bands, the top band, band 1 with band 2. So if we swapped it, all of these digits would appear on the top. And all of these digits are going to appear in the middle. Okay. And then, this block here, and I'll kind of help you keep an eye on this block. This block will end up right here, right? And then if we swap this band, band 3, with band 2, we'll move this block. We'll go up here, and it'll move to this spot. And since this is in band 3, this block here will move to here. And so this will be at the top, this will be at the bottom, and they will be symmetrical and opposed to each other. Same thing with this block here. If I told you up and I moved it over to the right, you'll notice this block would go up here, and then I swap it with band 3, it ends up in this area. And so now it's going to be in this corner, and it'll be symmetrical to this block right there. And by doing this, you're going to see, and I'm going to show you a new grid here. Okay, so let me show you the new grid. Okay, so I moved bands 1 and 2. I swapped them around, and then I moved bands 2, vertical bands 2 and 3. And this is what you end up with. This is an automorph, or nice, this is an automorph of the puzzle I just showed you. All right, that's the original puzzle. We just moved some of the bands around, and you end up with this. This is something we can work with a little easier. So automorphism was the first idea I gave you to. Now, there's a very specific rule that applies in this situation. The thing you got to notice next is that all these digits in this starting grid, and this is why I removed the digits I solved, has a mirror. Okay, so this one, you see all the ones and twos are mirrors. So this one has a mirror right here. And by a mirror, it means it's in the opposite column and the opposite block. This one, mirror with this two. This one, mirror with this two. Okay, so they all have a mirror. The threes have a mirror with the nine. This three with this nine, this three with this nine, and this three with this nine. So this is rotating all the way over here. And then within this part, if they're in the same column, they're just on the ends. Okay, cool. The fours mirror with the sevens. This four with this seven, this four with this seven, this four with this seven. Okay. The fives and the sixes right here and here. And then the 8 mirrors with itself. So this 8 has a mirror right here. If you flip this around like a record, you end up right there. This is important for the next strategy, the next rule that comes into play. It's the only easy way to solve this puzzle. If this puzzle has a unique solution, and which we know it does, and the puzzle clues are symmetrical, so each of these has a mirror. There's no additional, there's no missing ones. They all have a mirror. Then the solution is going to be symmetrical. What that means is all these digits are going to be somewhat symmetrical. All of them are going to have and be mirrored from each other. This is a rule, it's called Gurth's symmetrical placement. And it's GSP, and it was popularized by a person named Gurth in the Sudoku forum. I'll put a link below. And you think about it, if everything's symmetrical and the clues are symmetrical, it's got one solution. There's only one way it can be solved. And so we can use that to our advantage to place a digit here, a very crucial, critical digit. What you want to look at is you look in this middle band right here, and I'll color this up. You'll notice that the 1 has got a mirror with the 2, right? The 3 got the mirror with the 9. 4s and the 7s mirror each other, and the 5 and the 6. The 8 doesn't have a mirror. So what can go in this middle cell? That's what you got to ask. And it can't be 1, 2, 3, 4, 5, 6, 7, or 9, right? Because if you put this in the middle, where's its mirror going to be? The mirror can't be anywhere else in the block. The only digit that mirrors itself is the 8. The only digit that mirrors itself is the 8. So you can place the 8 right here in the middle in this puzzle, okay? And we'll highlight that as a green digit. This is awesome stuff. So Gurth's symmetrical placement lets us know that this has to be an 8. And if you find value in what I just showed you, consider buying me a coffee, or simply just click on the super thanks in YouTube. I really appreciate it. I want to bring you this idea to life. It's hard to read about in the forums. I'm putting in a video for you. Now, where does this 8 translate in our original puzzle? And if you just want to solve the puzzle in this form, I put a link to that down too. I call it the morphed version of Thunderstorm. Let's go back to the original puzzle. Remember, this was the empty block. So we go here, and we're going to get rid of our colors. And where was the empty block? The empty block, we flipped and moved over here. All right? So the green cell equates to right there. So what does that mean? That means this cell has to be an 8, because both these puzzles are solved with the same strategies, techniques, and if you move the digits, they're all going to be in the same place. That's got to be an 8. Okay? Now, let's see what we can do with that knowledge. They put an 8 there. Why don't we just go back and rehash the stuff we already found, right? So we know that with these ones, we got a 1 right there. And this one, we got a 1 right there. If you remember, we got with these 2s, you got the 2 there and the 2 there. If you remember, there was a pointing pair of 3s here, which allowed us to solve this for a 3. all this applies in our original puzzle. And then with the 9s, if you remember, pointing pair of 9s allows us to solve this cell for a 9. Okay, now we're back, but we know this cell is an 8. How's that going to help us? All right, let's see. Let's look at column 8. We need a 1, 2, 4, and a 7. Okay, so 1, 2, 4, and a 7. You might notice that you got the 1, 4, 7 here. This has got to be a 2. And then the 4, 7 here means this has to be a 1. With the 4 here means that's your 4 and that's your 7. Cool. And with these two 7s, that's a 7 displacing that Snyder 3. All right, looking good so far. And then we can fill this part out a little bit. Looks like we got a 2, 5 naked pair. And we're going to do a little bit of pairs here to kind of fill out the rest of this grid. Okay, and let's look across this way. What else can we do? Well, with these two 4s, we can solve for a 4 right there, displacing that Snyder 9. Okay, and with these two 9s, we know this is going to be a 3 or a 9. Okay, these two cells have to be a 1 or a 6. Okay, and what we got here looks like a 1 or a 6 as well. I got my 1 right there, so we can do the 1 and the 6 right there. Nice. And then up here, we have the 3, 9 naked pair. What we're looking for, it looks like a 2 and a 5. Well, I got my 2 right here. So here's your 2, and there's your 5. All right, so far, so good. What else can we do with this knowledge? Well, with these two 5s, we can put a 5 right there. That's going to give us an 8, 9 right here, right? Naked pair. Naked pairs also act as a pointing pair. So now we know a 9's in one of these spots. This can no longer be a 9. That's got to be a 3. That's got to be your 9. We can clean that up. And then with the 8, 9 here, there's only one digit remaining in column 9. So that's got to be a 9. And then this is going to be a 3 and an 8. Okay, so I can put my 3 and an 8 right there. Now what can we do? All right, after filling in all of that, let's look at column 3. Okay, column 3. You want to go where you have the greatest amount of restrictions. We have 5 digits filled out. A 1, 2, 4, 8, 9. We need a 3, 5, 6, 7. And let's look over here in block 5. Okay, you got this 3 here, you got this 3 here. So the 3s are limited to these two spots. Well, the 3s are limited to these two spots right there. So this creates what I call a mini X-wing. Okay, and since this is a mini X-wing, a 3's got to be there, there, or there and there, because they're limited to rows 5 and 6 in blocks 5 and 6. So where can a 3 be, or does it have to be in block 4? It's got to be in row 4, because a 3 can't be anywhere else along the row. And since we have a 3 here and a here, this is a hidden single 3. All right, we can solve that. Awesome. And knowing that, now we can keep working down this column with what I call my neat naked triple trick. All right, we need a 5, 6, 7. I got a 5 and a 7 right there, and I got a 7 repeater right there. Whenever you have that situation, you can solve all 3 of these cells. This has to be your 6. This is the only place the 5 can be, and that's got to be your 7. Okay, after solving that, now let's look in block 4 for where a 7 can be. You got this 7 here and this 7. We can solve this cell for a 7. And then you got the 6, 9 coming down. So the 6 here, the 6 cutting across. We know that this has to be your 6. And now the 9 can only go right there, which is going to disambiguate our 8 and 9 right there. Looking good. Awesome. And then with these two 9s and these two 9s, we can solve for a 9 right here. Cool. This is going to give us a 4, 8 naked pair. And then we have a 2, 5 here. I'm going to show you my neat, I call it right angle trick. We're going to be able to solve this cell because of this digit right here. Because the 5 is right there, this is the only place for a 2, meaning that has to be a 5, that has to be a 2. All right, my right angle trick. And then after doing that, we're going to come across here, kind of similar situation. You got the 4 here, means we can solve this cell all the way down there. Because there's 4, this has to be your 8, which means that's the 4, that's going to be your 8. Awesome. And now let's look for more restriction here. We only have 2 digits remaining. We need a 4 and a 6. Well, the 4 is going to work with us again. There's your 4, and there's your 6. Now we can disambiguate the 1, 6 up there. Okay, and with these two 1s, I want to knock out the 1 right there. Looking good. And what we have left is a 5 and a 7. Okay, 7's right there. Boom. I'm going to do some cross hatching. 7 and a 5. And with these two 5s and this 5, We can solve for 5 right there, displacing that Snyder 3. And now we know the mini X-Wing, 3 to 8. We're going to disambiguate that. So I have 1 cell remaining. So I will come over here and solve that for a 4. That's what I don't see. I'm missing a 5 and an 8, so I just got to pull it over. I see my 5. I'm going to pull it from block 5. So that's got to be your 5. That's got to be your 8. I don't see an 8 in here, but I see an 8 right there. With this 8, we know we can solve this cell for an 8 now, which is going to squish the 4 into this spot. All right, we have 2 cells remaining, a 6 and a 7. Here's my 6. I'm going to pull it on down. That's your 6, and that's your 7. Watch this next video to learn something else new from a Philip Newman puzzle. I hope you enjoyed this, and I want to thank you so much for watching.